Good morning, Year 5. Welcome back to another maths lesson. I hope you all had a lovely weekend and you're ready for another week on our topic of position and direction. So, like always, we're going to start our maths lesson with our flashback 4 questions. So you've got your 4 questions here and our bonus question. So I'd like you to have a go at all of the questions because it will really help you with your math skills in the future. So please pause the video to answer these questions in your maths book. Okay, let's have a look at the answers together. So question 1, 4 is a factor of, and the answer could be anything in the 4 times tables. So 4 is a factor of 4 because you multiply 1 and 4. 4 is a factor of 8 because you multiply 2 and 4. 4 is a factor of 12 because you multiply 3 and 4, and so on. So your answer can be anything in the 4 times tables. Question 2, find the factors of 42. So if you think back to when we looked at factors, we did that table with 1 something, 2 something, 3 something, which really helped us eliminate what numbers were not factors of 42. So the answer to this question is 1 and 42, 2 and 24, 3 and 14, and 6 and 7. Question 3, work out 3,157 times 4. So you could have used your column method to get the answer of 12,628. Question 4, add together 6,483 and 1,999. So you could have used your column addition to get the answer of 8,482. And onto our bonus question. What time is it and can you say it in another way? So our little hand is in between the 8 and the 9, so we know our hour is the 8. And our big hand is on the 12th minute. So therefore we know the time is 8:12. So this is what it would look like if it was AM on a digital clock. We say 12 minutes past 8. And if it was PM, it would look like this, 20:12. So, Year 5, could you please pause the video again and mark your answers in a different coloured pen? Give yourself a tick if you got it correct, and give yourselves a dot if you got it incorrect. And if you got it incorrect, just look at the answers and see where you made your mistake. Okay, so as I said, we're going to be moving on with position and direction today. And today's lesson is going to be about identifying lines of symmetry on a shape. And before we begin, like usual, I'd like you to pause the video and write the date in yellow nice and neatly in your maths book. So the date is the 8th of the 2nd, 21, and the LO is to identify lines of symmetry on a shape. So make sure you do that nice and neatly and underline with a ruler. Okay, now we're going to start our explore phase step 1. And I've got a question for you with a picture. And my question is, what is a line of symmetry? So you can look at this shape and think about these lines and why these lines are showing symmetry. So pause the video if you'd like to look at the photo for a bit longer. And if you think you know what a line of symmetry is, that's great. And we'll look together on the next slide. Okay, so I'm going to read out this definition and then you can have a look at the pictures here to help you visualise what lines of symmetry are. So a line of symmetry is a line that cuts a shape exactly in half. This means that if you were to fold the shape along the line, both halves would exactly match. So if I look at this rectangle here, if I was to fold the shape along this horizontal line, both of my folds would be exactly the same, and it would be the same if I did this line here as well. So if I folded these two halves, they would look exactly the same. And when a shape does have lines of symmetry like these, it's called a symmetrical shape. So these shapes here are all symmetrical shapes because they have lines of symmetry. So I would like you guys to have a little go with a piece of paper if you have one. And what I want you to do is just fold it in different ways and see how many lines of symmetry there are. So remember, lines of symmetry are when the folds are exactly the same. They look exactly the same when you fold the piece of paper in half. So pause the video and go and get a piece of paper if you'd like to have a go at that. And if not, we'll continue the lesson on the next slide. And before we move on, I'd just like to address a misconception that some people have. So if we look at this square here, a square has 4 lines of symmetry, and these are the 1, the 2, 3, and 4. So it's not 1, 2, 3, 4, 5, 6, 7, 8. These are long lines that go through the shape like folds or cuts. So the square here has 4 lines of symmetry, not 8. And the rectangle has 4, and this diamond shape here as well has 4. So it's important that you know that these lines go all the way through the shape and count as one line. Okay, and now we're going to compare 2 different shapes and think about, will both of these shapes have lines of symmetry? So here I have a rectangle, and here I have a parallelogram. And remember that a parallel shape is a shape that sides will never intersect. So these lines will keep going and never meet. And a good way to remember what a parallel shape is to look at the word parallel. So it has 2 L's here, which look like parallel lines to remind us that they'll never intersect if they keep going. Okay, so as I said, we're going to think about, do both of these shapes have lines of symmetry? So you can think about, if you folded these in half, down the middle or across, would the folds be exactly the same? So what I want you to do is just pause the video and look at these shapes and imagine folding them in different ways and think about if they're symmetrical shapes. Okay, so here is the answer to that question. So a rectangle is a symmetrical shape because you can fold it in half and the folds will be exactly the same. A parallelogram is not a symmetrical shape because if I folded here down the middle, when I brought this fold over to this side, it would be different to my existing fold. So a parallelogram is not symmetrical, however a rectangle is. Okay, so I've got a little problem for you to solve now, and that is that I want you to identify which shapes you think are symmetrical and which ones are not. So you need to look at these 6 shapes on the screen. We have a rectangle, a pentagon, a parallelogram, a trapezoid, an isosceles triangle, and a rhombus. So again, think about, if you folded these shapes in half, would your folds be exactly identical? So you could write in your books a rectangle with a tick or a cross. So a tick would mean that it is symmetrical and a cross would mean that it isn't. So pause the video and identify which shapes you think are symmetrical and then which ones are not. Okay, so here are the answers to that question. So our symmetrical shapes are our rectangle, pentagon, isosceles triangle, and our rhombus. Because if we folded them at different points, our folds would be exactly the same. And like I said earlier, with a parallelogram, we cannot fold it and have identical folds. If I folded it down the middle here, when I bring this corner over, it would end up here. So our folds would not be identical. And the same with this trapezoid. So if I put my fold down here, once I bring this side over, my folds will be different and therefore it is not symmetrical. However, like we said earlier, these shapes will have identical folds. Okay, so now that we've established these shapes are symmetrical, I now want you to identify which of these shapes have more than one line of symmetry. So you could draw them in your books and draw the lines of symmetry, or you could look at the screen and imagine where they would go. So pause the video and now identify which of these shapes have more than one line of symmetry. Okay, so here is the answer to that question. So the only shape that only has one line of symmetry is our isosceles triangle. The other shapes, such as the rectangle, the pentagon, and the rhombus, have more than one line of symmetry. So let's have a look at our rectangle first. So our lines of symmetry are going vertically and horizontally here, and if we folded our rectangle on those folds, our folds would be identical. They'd be exactly the same. So therefore a rectangle has 2 lines of symmetry. A pentagon has 5 lines of symmetry. And if we think about our 5 vertices of the shape, our 5 corners, each of our lines of symmetry is going through that vertex. So as you can see, each vertex has a line of symmetry through it. Okay, and our rhombus, bit similar to our rectangle, our lines of symmetry are going vertically and horizontally, and if we folded our shape on those lines, the folds would be identical. However, if we were to fold our isosceles triangle here, our folds would not be identical, because if this part was folded over to the top, it would be bigger than our top fold. So therefore, the isosceles triangle only has 1 line of symmetry. So what you could do now is pause the video and have a look at your answers, see if you got them right and see what mistakes you made if you got any incorrect. Okay, so here is the step 1 of the worksheet. So you've got 1A where you identify which shapes have at least 1 line of symmetry, and 1B is where you draw your own shape and see how many lines of symmetry it has. So you can draw your shape and draw the lines of symmetry in a different coloured pen, because that might help me see the difference. Okay, now we're going to move on to our explore phase step 2. So I've got a triangle on the screen. It's a right angled triangle, and Miss Griffiths has drawn a line of symmetry on this right angled triangle. And I want you to think about, is her line of symmetry correct? Will our fold along this line have identical folds? So pause the video, have a look at the image and think about whether Miss Griffiths has drawn the correct line of symmetry. Okay, so the answer to this question is that Miss Griffiths is not correct. And that is because a right angled triangle has 0 lines of symmetry. And if I was to do my line of symmetry through here, because it's not an equilateral triangle, this vertex here is higher than this one here, and therefore our folds would not be identical. So a right angled triangle has no lines of symmetry. So well done if you got that correct. And if you didn't, have a little look at the shape and think about how the folds would not be identical if we were to fold it in half. Okay, Miss Griffiths has said another thing about shapes and lines of symmetry. And this time, Miss Griffiths also said a circle has 2 lines of symmetry. Year 5, can you prove her wrong? Where has she gone wrong? And I want you to think about how many lines of symmetry a circle does have. And this is an interesting question. So pause the video and try and prove Miss Griffiths wrong and explain why she is wrong. Okay, so the answer to this question is that a circle has an infinite line of symmetry. Does anyone know what the word infinite means? You might have heard it when people say to infinity and beyond. So if a circle has an infinite line of symmetry, that means that it can just keep going on forever and ever and ever, because we can go across and across and across and across, and it will just keep going on and on and on. So therefore, there is no set answer to how many lines of symmetry a circle has. So that's an interesting fact for you to all think about. Okay, so year 5, I've now got the step 2 questions of the worksheet on the screen for you to complete in your books. So step 2A looks at correct lines of symmetry and whether you think these are the correct lines of symmetry or not. And then 2B involves you drawing these shapes in your book and drawing at least 1 line of symmetry on each shape. If you feel like you're confident to do more than 1 line of symmetry, that is fine as well. So pause the video to complete step 2 of the worksheet in your books now. Okay, and we've got 2C of the step 2 worksheet on the screen for you now. So it links back to our circle fact. So you should be able to answer this one nice and easy. Okay, year 5, now we're on to our step 3 input. So we've got a grid on the screen, and I want us to think about how we can draw a symmetrical shape on this grid. And we need to use a minimum of 6 squares. So firstly, think of a symmetrical shape, and then think about how we can use 6 squares to draw it. And if you feel confident, you could pause the video and have a go at this question in your books. And if not, keep watching and we'll have a look together. Okay, Year 5. So as you can see now, I've put on the screen a sketch of a symmetrical shape using a minimum of 6 squares. And just because I've said minimum of 6 squares, that doesn't mean you can't use more. So as you can see, I've thought about what shapes are symmetrical. And the first one that popped into my head was a rectangle. And then I thought, can I draw a rectangle using 6 squares? And I thought, yes, I can. So here I've done 3 squares for each column, and all together it makes a rectangle. So obviously this is just rough. So when you do this in your books, you could sketch it a bit neater than I have. Okay, so that is how we use squares to draw a symmetrical shape. Okay, so here is the step 3 questions of the worksheet. And again, you've got a similar question here. So you need to shade a maximum of 8 squares to make a symmetrical shape, and try and pick one different to a rectangle. Try and be a bit more creative. And then for 3B, you need to complete this grid in your books, filling in the different boxes. Okay, and lastly, this is the extension question of the worksheet. So for those of you that are feeling really confident, have a go at this one by yourselves. Okay, Year 5, well done for completing your independent work. Here are the step 1 answers of the worksheet. Here are the step 2 answers. Here are the step 3 answers. And here is the extension answer. Okay, Year 5, make sure you've marked your work and checked you understand everything. And I hope you have a lovely rest of your day, and I'll see you again soon for some more maths. Bye.